Greetings, everyone. I hope you had a very good day. Today we are going to work with Leontief input-output matrix. One of the best models in which links actually what we studied in matrices, in linear transformations, and it's really one of the best models to see how it is linked those algebraic definitions and this linear algebra questions with something in reality. Okay, of course all of our course notes, references on Moodle. I will take the chance to tell you that it's really very important for you just to enter the midterms. Okay, try some of the midterms that already exist on Moodle. You will have an icon written on it, the big day. Please do go through it. Some of you did, like Omar, so try to go through it. You will find the mock exam, just enter the mock exam, try the questions, try to put a time for you for an hour or so, just to see how it's gonna be. See the questions step by step, read them carefully, and start working with them, okay? This is really very important. In order to try everything, to try yourself, to try the questions, the thinking, the time, and everything. Also, the recorded lectures, you will find them on the YouTube channel, so I think we will be in a very good shape. I just want you to see this slide. It's related to the linear transformations. I have recorded a lecture for you going through the revision of, the linear transformation part 2. I have recorded and I've sent it to you all. Okay, this is one of the parts over there which speaks about how to have a composite linear transformation. And what we mean about a composite linear transformation. It's really very simple. It's like trying to move a linear transformation from x into b of x. We know that the linear transformation is x equal to a times another value or another vector. This is gonna move you from R2 into R3 or from R3 into R3, as you know from the linear transformation. I can do double transformations. I can move, for example, I can move from R2 into R3. Then I can jump again from R3 either into R2 or from R3 into another R3 or from R3 into R4. I can do whatever I want. This can be easily done either by making the first movement of linear transformation, then doing the second step using the transformation matrix A, or just to multiply A and B together, and you will move from the beginning of X till the end of this transformation. This is written in here. Let's see, that's a linear transformation T1, which moves stuff from Rn into Rp. So that's the input, Rn, and the output after transformation, it's gonna be Rp. Okay, and the T2 will receive the output from here, and it will move it to Rn. If I want to move directly from N to M, all I have to do is to multiply the matrix of the linear transformation of T2 times the matrix of the linear transformations of T1. I just only have to multiply these two matrices responsible about this linear transformation, and I will be able to move X to the end of line, as you see on this slide. That was explained in the previous lecture, but I thought just to redo it with you again once more. Now, اتفضل.
هو دلوقتي ايه يعني هو الاثنين حرفيا اللي قبل الايكوال هو اللي بعد الايكوال، في فرق، ايه الفرق؟
ما في اللي قبل الايكوال. This is describing that I will get the transformation matrix of T2 composite T1. How to get this transformation matrix, which will be responsible about moving X to this form, ABX. How to get this linear matrix? I will get the matrix of the linear transform of T2, then I will multiply it by the matrix of linear transform of T1. Multiplying them together will give you a new matrix, which is gonna be responsible about the transform from the beginning to the end. You read what I'm saying? So that's the symbolization that I will move between two steps. Moving the linear transformation, the first from Rn into Rp, then from Rp into Rm. Okay? This is the first transform, that's the second one. The composite means you will move from N up to M. The linear transformation matrix that's responsible about moving you from the beginning till the end directly, okay, is the multiplication of the linear transformation matrices, the second one times the first one. Do you read me? Okay? Okay, done. Now, as an application in chapter 1, we will study one of the best models to outline this or to explain this application, okay, which is the Leontief application. So it is a direct application of linear algebra in macroeconomics planning. Okay, the Leontief input-output matrix is a way to model how industries or firms depend on each other's goods as inputs. This model explains to you, if I have more than one sector, as we will see, like sector 1, sector 2, sector 3, that's the sectors that your economy will depend on, okay? So the production or the movement of each sector of these sectors will depend on the outputs of the other sectors. So, as the example that we will see, but I will just give you a hint for the time being, if I have an economical system which depends on 3 sectors, let's say industry, let's say or manufacturing, agriculture and services. Agriculture, it's whatever you cultivate and you will use some of it in manufacturing, okay? So agriculture will feed the manufacturing. Also, manufacturing sector will feed the agriculture by the use of machines and so on. Both of them, they will feed the third sector, which is the services. The services means the people who work in agriculture and in manufacturing, or the other services between them, like transportation, like movement, like facilitation, like logistics, whatever. So actually, these 3 sectors depend on each other in order to perform or to produce. So once more, the Leontief input-output matrix is a way to model how industries, what we mean about industries or firms, depend on each other goods as inputs. So each one of them will depend on the other's output as an input for this sector. Okay, it helps compute the total output required to meet any final demand. The final demand, it means the rest of the production that will go for the free source. Who is the free source? The general users, or for sending outside your economical system. So once more, it helps compute the total output required to meet any final demand, accounting for all direct and indirect requirements. Okay, here is Leontief. He lived between 1905 up to 1999. He's a Nobel Prize in Economics in 1973. He has been notable for a research on how changes in a single sector of an economy will affect on other sectors. Okay, and also he was a professor in Harvard University and New York University. I've taken this information from Wikipedia, so you can easily find more about the history of this gentleman. Okay, the model. It is a mathematical model admitting that supply and demand are balanced, okay, and the amount needed to production is proportional to the amount that's being produced. This is the general equation of Leontief input-output matrix, which simply explains that the amount produced from all sectors is going to equal to the intermediate demand plus the final demand. So the production should equal to the demand. Okay, whatever you reduce should equal to the demand. And this way, you will have a balanced production and the demand equation. Okay, the demand, it's gonna be an intermediate demand, which is the demand required for all sectors to be up and running. in order to be able to produce. The remaining parts from the production will go to the final source, which is represent the final demand. Step by step, it will be obvious for you. Okay, the equation is like this. X stands for the production of any sector. So if I have an economical system and it contains 3 sectors, I will have a column here, which is X1, X2, X3, Sector 1, Sector 2, Sector 3. A represents the technological matrix or the technical matrix. We will see how to do it. And then X is a part of the production. So this is the percentage of the production that will be exhausted within the various sectors, okay? And the remaining will be the final demand. Okay, Leontief input output, this is the general equation, and that's the definition as I told you. X is the total output of vectors, or the total in production of each sector. AX, it is the intermediate demand, inputs needed to produce for production. Okay, then D is the final demand, consumers, exports, governmental, whatever. That's the final source. Okay, basic idea behind Leontief model in microeconomics describes how different industries or sectors of an economy depend on each other to work together. None of the sectors will stand by itself. So agriculture by itself, if I'm talking about an economical system with 3 sectors, agriculture, manufacturing, and services. If I look to agriculture by itself, it will depend on manufacturing. In order to be able to do agriculture, you will need some of the manufacturing. It will enter into machines, into services, and whatever, and also the services. If I went to manufacturing, I will need to take some of the output of the agriculture to help me with manufacturing, and also I will take some of the services, and so on. Okay, each industry both produces goods, which means output, and uses goods, which means an input. So each sector will have an input, then it will have an output. Okay, from other industries to produce its output. Suppose there are n industries or sectors, okay, of an economical system. The input, output, or technology matrix, which is A, that matrix, which is A of IJ, all the elements that exist in A, can be expressed as the following. AIJ, the amount of output from industry I, needed to produce 1 unit of output of industry J. So this is how each one of them will depend on the production of each sector by itself. Okay, so column J tells you all the inputs required from other industries to produce 1 unit in industry J. The case of an economical system of 3 sectors, here we go. That's the example that I was telling you about. And that's the main example in our slides. If I'm talking about in an economical system, which depends on how many sectors? 3 sectors. So this is actually, it's gonna be X 3 in 1. X1, X2, X3. X1 stands for one of these sectors. Let's call this is X1, that's X2, and that's X3. Okay? So X1 for manufacturing, X2, let's say for agriculture, X3 for services. Okay? So this is gonna be a column, which means this matrix is gonna be 3 by 3. In order to be able to multiply it in another X, because it's the same production, it's a percentage from the production. And the final demand will be a matrix which is 3 by 1. This is what we will see. Of course, here once more he is explaining to you the input output, that's the X, the production, that's the intermediate demand. So once you are asking about the intermediate demand, this is the part that we need. And the D is the final demand. I believe this example will make things much easier. Here he is giving you the technological matrix or the technical matrix. This is matrix A, which is 2 by 2. Once I told you that matrix is 2 by 2, that means my economical system that I will explain here depends on how many sectors? 2 of them. Okay. So let A be the matrix of technical coefficients of an economy with two sectors. X, the vector of production of each sector of these two sectors. And D, the vector with the final demand, the remaining values that will be exhausted by the consumers or by the government or to export outside or whatever. Okay, the first question, if I have this information in front of me, he's asking you, what is the amount of intermediate consumption, okay, for each sector of X? I'm sorry, for each sector, if X is given by 40 and 12. So if I am producing 40 units from sector 1, 20 units from sector 2, what's the amount of the intermediate demand? Once more, what's the intermediate demand? The percentage that will be exhausted during the production of the other sectors. How to bring it? It's really very simple. All I have to do is to multiply A, which is the technical coefficient matrix, times X, which is the production. So all I have to do to know this, I will multiply these two matrices together. This is the technical matrix, are you with me, Muhammad? Times the output or the production. So now it's 20 and 12. Multiply the first row by the column, it will give you 20. Multiply the second row by the first column, so it will give you 12. So out of my production, I will exhaust, okay, 20 from sector 1 and 12 from sector 2. Once more, that's the total production. The total production is 40 from sector 1 and 20 from sector 2. What are you going to exhaust or to digest inside your economical system are those two values. What's remaining for final demand? So 20 monetary units of the goods are in sector 1 and 12 monetary units of the good of sector 2 will be exhausted, okay? I can ask you about each one of these values. It's very, very simple. I can do the math, multiplying these two matrices, and I will have the data. Okay, the second question, what is the amount of the final demand? Omar, it's very, very simple. Once more, X production, AX intermediate demand, and D is the final demand. So simply, if I want to get the final demand, all I have to do is just to move this matrix to the other side. So I will get the difference between the production and the amount exhausted during the production. This is going to be the final demand. So I'm producing 40 units in the first sector. I'm consuming 20. So the remaining demand is 20. I'm producing 20 from sector 2. I'm exhausting or digesting 12. So the final demand will be 8. Very simple. So D is simply 40 and 20, which are the production. معايا محمد? Minus the intermediate, which was 20 and 12. So the final demand will be 20 and 8. Okay. This is how to evaluate your final demand. I think this problem pointed out how to evaluate the intermediate demand and how to evaluate the final demand. Let's look further into details. I'm going to talk about, in specific, the technical matrix or the technical coefficients Aij. How to evaluate them? It will be evaluated from this ratio. The amount of production of sector I, row, okay, used in the production of sector J, divided by the production of sector J. This is how to get the ratio. Once more, guys, look to these percentages. I have 1/4, which is simply the percentage of contribution of sector 1, okay, from the production of the first sector. This value stands for the amount that will be exhausted from the first sector, but with sector 2, and so on. So each one of them, it has a description. Okay, let's go into details. This is once more, the demands are balanced, so the amount produced equal the intermediate plus the final. Okay, that means this equation, which stands for X equal to AX plus D, that's the intermediate, I need to talk about this matrix of technical terms. Okay, this is the intermediate demand, and that's the final demand. So it's set. I believe now it's already in your mind. Okay, let's skip this part. AX is the intermediate. خلاص احنا عرفنا كل ده خلاص تعرفوا دلوقتي. Okay? So once more, this is how to evaluate A of I and J. The production of sector I, as I told you, required in the production of sector J divided on the total production of sector J, and this is also the definition once more for you. So an economical system of 3 sectors, I have just tried to make the previous photo bigger for you. Let's look to each one of them. Do you see these arrows? Do you see these arrows? Muhammad.
No.
Look to each one of them. X1 is the manufacturing, so this is the first sector. X2 is the agriculture, this is the second sector. Of course, I can call them as I want. So I'm putting this is X1, that's X2 in order to arrange my production and the equation, the system. And this is X3, the services. Let's look in specific for each sector of these sectors. Omar, look at manufacturing. The arrow represents the output. Okay? This is a part of its output. As you can see, it is entering once more in the manufacturing. Because manufacturing by itself, it will give you manufacturing, and some of this units will be used in manufacturing by itself to keep it up and running. You understand what I'm saying? So that's the part that will be exhausted by manufacturing. Look to manufacturing, it will send from its output to services, and also will send from output to agriculture. Same way like. This sector by itself, it will depend as an input on itself and on the agriculture and also on services in order to be able to be up and running. And that explains how each sector of these sectors depend not just only on himself, but on the other sectors. You understand what I'm saying? So, as you can see, those are the 3 services, and this is the open source that we spoke about. This is the final demand. After you finish your requirements here from the output, the remaining will go out for the outsource. Either consumers, exporting, government, whatever. So, if I look to services, after finishing everything, the remaining of services will go to the end users. You read me? So they can use it either in government or send it outside or whatever. Same way like if I'm talking about agriculture. As you can see, agriculture is feeding as an input services. And the services by itself will be fed also from manufacturing. And also services will be needed for itself. Okay? And the rest of all of this will go for the open source. That's an complete economical system. Each sector will serve itself and the others. Okay? Very good. طبعا the amount is balanced as I told you. So once more, these are the 3. So if I'm trying to build this equation, which was X, remember, I have X, which is the production, equal A, which is the technical matrix, times X, which is the reduced part, plus the final demand. Okay? Let's reform each equation. So I will start by the equation of the first sector, the first equation. Okay, the first equation, the production is X1. So X1 stands for manufacturing. So as an input, you will have A11 times X1, which is the part of production that will be used in manufacturing, plus A12, which is the amount of the production that will be used from agriculture and goes into manufacturing. And that's the part or the ratio from the services that will be exhausted in X1. And after all of this, the remaining will be D1. Same way like that's for sector 2 and for sector 3. Now, if I'm talking about a system of 3 sectors, the technical matrix or the technical coefficient matrix will be a matrix 3 by 3. Let's do it step by step. Let's see this slide. course, here he's describing to you how to get the A, I, and J, industry I, J production, and so on. I will skip it already, I've told you about it. Let's look to these amounts. Let's look to these amounts. These amounts are given to you based on the given data. This system produces 300 units, or monetary units, from the first sector, 200 monetary units from the second, 100 monetary units from the third sector. How the 300 is distributed? Out of the 300, I will talk about the X1, the first sector. Okay. Out of the 300, 150 units will be used in manufacturing. Okay? Okay. And then 20 plus the 150, it will go out into services. And also, the manufacturing will send 80 units for agriculture. So simply, if you add these units, 20 plus 80, it's gonna be, plus 150, it's gonna be. So out of 300, you will have for final demand 50. That's the remaining. It's really very simple, logic. Same way like for agriculture. Agriculture in general, producing how many units? 200. 60 of them will be exhausted in agriculture to keep it up and running. That's the way. If I'm cultivating rice or whatever, I will sell some of it and I will keep some of the rice in order to start agriculture next season. Okay, they will be what I'm going to exhaust in keeping this planet going. Do you understand what I'm saying? Okay, and also in agriculture, it will send 60 units from its total production will be exhausted in manufacturing, and also it will send 10 units to services. So if you add them all together, you will get the final demand. Okay, X1 and 1. Where is X1 and 1? X1 and 1, it means the 150, which is the part that will be exhausted in the first service. Let's see what stand for, or how to describe it. So X11, it is the part of the production of the first sector. What's the first sector, ya Omar? Manufacturing, okay? That will be used in this sector, manufacturing, which is 150. Okay, let's go for X1 and 2. What is X1 and 2? It is gonna be the part of production of manufacturing. That's gonna be the input, okay? That will be used in agriculture. That's the part of the production that will be sent to production. Same way like X13, it will be the part from manufacturing that will be sent for the services, which is 20. Same way like each one of them. That's for the second row, which means the second sector. This is stand for X3, which stand for the third sector, and so on. Now, from all of this, I can now write the technological or the technical coefficient matrix. The inputs of each sector on the other are those on the images. This is X1 and 1. Okay, so this is X1 and 1. Okay, this is X1 and 2, which goes into the agriculture. This is X1 and 3, which goes from the manufacturing sector into the services. It's system. Now go to X2. If I went to X2, this is X2 and 1, which is the amount that will go out from agriculture to feed manufacturing. This is X2 and 2, which is the amount of agriculture that will enter agriculture. X2 and 3, which is the amount from agriculture that will go and feed services. Same way like for services. Okay, X1, X3 and 1, it is the amount, okay, that will go from services in order to feed manufacturing. And X3 and 2, it is the amount from services, X3 and 2. That's X3 and 2, okay? Just a second, please. This is X3 and 2, which is the amount from the production of the sector 3 that will feed agriculture. Then I will have X33, which is the amount of the services that will be used to feed services, to keep it up and running. The difference is all these amounts, I'm going to use them one by one. So let's go in order to get the ratios that will help you in to get the A matrix, which is the intermediate responsible or the intermediate demand. It's very, very simple. Okay, I will divide each one of these xi and j divided by xj, the total amount that will be produced. So for the first column, let's look to this column. I will divide the first column. This is column number 1. Those numbers 150, 80, 20. I'm talking about the denominator. It's x1 and 1, x1 and 2. Look, x1 and 3. So that's the part, okay, that will be exhausted from the production of the first sector in the 3 sectors. This is for the second sector. That's for the third sector. I'm talking about the denominators. Okay, I will divide the first column by the total production, which is 300 for the first sector. I will divide the second sector, which is the agriculture, by the total production of agriculture, which is 200. I will divide the third sector, معايا محمد, by the total production of services. Now I have the ratios. معايا مهند؟ مهند صح؟ Okay. بص يا مهند، شايف it's ratios. So it's the ratios of the production. Now if I multiply this matrix by 300, 200, 100, I will have the intermediate demand. And the rest will be the values that will be needed in the final demand. These are the ratios as we saw together previously, representing all of this. So taking this is the matrix that we spoke about. If I want to have intermediate demand, it's very, very simple. All I have to do is to multiply this matrix by the values 300, 200, 100. And now I can get D. Okay? Simply by multiplying these values, that's x equal to this value times x plus the column of D. So D will have a D1, which is the final demand from the first sector, which is the amount that will go for consumers, for government, for exporting, whatever. Then I will have D2 and I will have D3. If I want to get the column of the final demand, how to do it? I will multiply the first row by this column. So this amount will be multiplied by 300, which is 150. Let's write it down. Let's try the first one. Okay, so 300, 200, 100. That's the intermediate demand column. Multiplying these values by those guys, 0.5 times 300 is gonna be 0.1 times 200 is gonna be 0.2 times 100 is gonna be, okay, 0.2 times 100 is gonna be 20, 0.1 times 200 is gonna be 20, and this is 150. Okay, so if I add them together, it's gonna be 290. 190. Okay, let me check بس just a second. معلش ثانية واحدة. نتأكد بس من النمبرز اللي في السلايد اللي فات. Okay. So once more, 0.5 times 300 is 150. 0.1 times 200 is 20. 0.2 times 100 is 20. Let's do for the second row. 0.2 times 300, it's gonna be, I believe, 60. 0.3 times 200 is gonna be also, I think, 60. Am I right? 0.1 times 100, please evaluate with me. It's gonna be 10. Same way like for the third row. 0.1 times 300 is gonna be 30. Then 0.4 times 200 is gonna be 80. Am I right? Plus 0.3 times 100, which is gonna be, and this is plus D1, D2, and D3. So in order to get this column, all I have to do is to evaluate the value. 300 minus, those are 190. Out of 300, so D1 will be 110. Okay, 60 plus 60 is gonna be 120, plus 10, 130 out of 200, so the final demand will be a 70. Same way like 30 plus 30, okay, 0.1 times 300, I think we made a mistake. This is 30. 0.4 times 8 times 200. Please try to multiply it. 0.1, so it's gonna be a 20 times 4, so it's an 80. 0.3 times 100, which is gonna be a 30. So I will add them together. This is 30 plus 30 plus 80. 140.
دي نيجاتيف 40.
لا ما ينفعش طبعا.
ما ينفعش.
لان ده معناه ان D3 is missing values. Okay? ف it seems like ان في حاجه في المالتيبليكيشن ده مش مظبوط. Let's try it once more. In the previous slide, I will check the numbers. ايه؟
اخر واحد كانت 100 ولا 150؟
مش فاكر 100 or 150 I don't remember actually.
في سلايد فاتت.
اوكي بس هو المفروض ان انا لما اضربهم هيديني ايه؟ الفاينل ديماند. ممكن الفاينل ديماند ما يبقاش ساتسفايد. اوكي؟ سو اتس بالماينس. اوكي.
ممكن تبقى بالماينس عادي ولا لا؟ الفاينل ديماند.
الفاينل ديماند بالماينس معناه ان عندك شورتج. البرودكشن بتاعك انت لسه required services. اوكي؟ طبعا خلينا نتكلم على دي اكتر. This is the problem that we already solved at the beginning, getting the final demand. So multiplying them together should result in values, and we already solved this problem previously. Okay, let's talk about this also. This is another example with the same. He's asking you about the matrix of the technical coefficients of an economy with two sectors, as you can see. The vector with the production of each sector, and D, the vector with the final demand for the goods produced. What is the amount of intermediate consumption? I can get it easily. All I have to do is to multiply A times X. So if I want to get the intermediate demand, which is A times X, it's gonna be simply multiplying 5 over 8, 1 over 4 times 1 over 8 plus 1 over 4 times the production. And the production that we have is 16 and 8. Let's do it together. That's 16 and 8. So the result will be 5 over 8 times 16. I believe it's going to be 10. Am I right? Then 1 over 4 times, I'm sorry. This is going to be 5 over 8 times 16. It's going to be 10 plus 2. So it's going to be 12 for the first sector. 1 over 8 times 16, which is going to be 2, plus 2, so it's going to be